The last section in this chapter is solving systems of equations using matrices. So in this chapter we have learned how to solve systems of equations using tables and graphs and substitution and elimination. And now we're going to learn the last way. And for the most part, the last way is most definitely the best way. So you will come to appreciate matrices for sure. If you don't understand matrices right now, you will. You need to know how to use them because they make life a lot easier. Trust me. All right, matrices shouldn't be a new concept to you. We did talk about them a little bit in Algebra 1. You've been using them in most of your classes anyway for several years. Any data table is actually a matrix. This table right here is a matrix. Anytime you use a spreadsheet, you are creating a matrix. Anytime you make a data table to graph a function, you are using a matrix. This happens to be called resistors in series. This would be something that you might see in a science class, earth science or something like that, physics. Some of you, maybe science classes when you're in 8th grade, would see a table like this. Basically, you're just recording data. It's an example of something that is a matrix. And that's what we're working with in this section. Before we can learn how to use matrices, we need to talk about what the parts of a matrix are. By the way, matrix is singular, matrices is plural. So, first of all, we have the name. I don't know how that happened. We have the name of a matrix. The name of a matrix is always a capital letter. It can be any capital letter you want. There are a couple of capital letters for matrices that are reserved, though. I is reserved and O is reserved. Anything else you can use? You'll find out. No. Capital I and capital O are reserved. No. They're reserved. They actually have a special purpose. We'll get to that eventually in this class, probably towards the end of the year. About April, we'll get into that. No. Okay, this is your matrix right here. You have a number of columns and you have a number of rows. The rows are horizontal, the columns are vertical. If you get confused, think about the Parthenon. It has columns. Columns are vertical. How many columns are there in this? 4. How many rows are there in this? 3. Okay. An element is any one entry in a matrix. So any one of those numbers that you see is an element. 8 is an element. 1 is an element. 5 is an element. Any one of those is one particular element. Think of the periodic table. Each one of those entries is an element. Same thing is true here. You can think of the periodic table as a matrix. The dimensions of a matrix are what we call m by n. M is the number of rows. N is the number of columns. It always goes row first, then column. In everything that we do with matrices, when we're talking about anything having to do with dimensions, row comes first, column comes second, always. So that's something you just have to kind of memorize. Now we have some notation here. If my matrix is called matrix A, capital A, then each element is a little a. And then the subscript that you see here is telling you what row by what column that element is. So for this element right here, this is row 1, column 1. That's why we see little a, 1, 1. Then for the second one, we are now in row 2, still in the first column, so that's why it is A, 2, 1. Row 2, column 1. For the third one, we have row 3 now, column 1, so that's why you see A, 3, 1. For the second one here, we have A, row 1, column 2. That's why we have A, 1, 2. So what would the next one down be? A, 2, 2. And the next one down? A, row 3, column 2, A3, 2. If we had another row over here, or another column over here, I should say, then this one would be A row 1, column 3, then A 2, 3, and then A. There you go. Okay. Now matrices can extend infinitely this way. You can have an infinite number of columns. It can extend infinitely this way. You can have an infinite number of rows. And the number of rows by the number of columns is the dimension of the matrix. So when you're working with matrices, you are actually working in multiple dimensions. Not just 1 or 2 or 3 dimensions, but in this case, you'd be working in 3 by 3 dimensions. Okay? So when we start talking about working in multiple dimensions, this is what kind of like what we're talking about. Let's take what we just learned and apply it to this matrix right here. We have the matrix capital B. So the matrix B equals that, and we're going to answer the following questions. What are the dimensions of this matrix? 2 rows by 3, so the dimensions are 2 by 3. Find the value of B22. That's row 2, column 2. It's always row first, then column. So little b22, come up to the matrix capital B, and go to row 2, that's this guy, column 2, that's this guy. So the number that got hit both times is that one right there. The answer is -5. B13 will be row what? 1, column 3. So row 1, column 3 gives me an answer of 0. B21 will be row 2, column 1, so the answer would be row 2, column 1, 4. And B32, what? That's a -5 right there. Okay, B21, row 2, column 1 is 8. Thank you. Row first, then column. Finally, B32. There is no row 3. We have 2 rows. Row 3 doesn't exist. So this is undefined. The proper way to say that is undefined. There is no row 3, so we can't even say anything about it. It's not really no solution. It's definitely not 0. Okay? It's undefined. All right. Use this ridiculous matrix to answer these questions here. So what are the dimensions of W? 5 rows by 4 columns. It's a 5 by 4 matrix. Find the value of W34. What is it? 9 is correct. 3, 4. The one that got hit twice was the 9. And W52 is 1. Row 5, column 2 is 1. So that was the introduction to matrices. Now we're going to get into more stuff involving matrices. We have some vocab that we have to learn. Augmented matrix. The word augment, to augment, the verb augment means to make, basically to change, to make bigger. Okay? You've probably heard the word augment before. It means to make bigger. Yes, so we're going to have a matrix and we're going to make it bigger. An augmented matrix is a matrix with the answers included. Punnett square? No. An identity matrix is a matrix with ones on the main diagonal and zeros everywhere else. I'll give you a picture of that. I'll give you an example. The identity matrix is usually referred to with the capital letter I, which is why we don't use I for matrices. An identity matrix, if it's a 3 by 3, would look like this. Ones down the main diagonal, that is the main diagonal, and zeros in every other position. That's an identity matrix. The dimensions of that identity matrix are 3 by 3. Identity matrices are always what we call square matrices. They have the same dimensions, 3 by 3. This is a square. 4 by 2 would not be square. 3 by 3 is square. So you could have another identity matrix of 2 by 2, and it would look like this. 4 by 4, same thing. The ones are along that diagonal. Coefficient, we already know. What is a coefficient? Number in front of the variable, yeah. The number in front of a variable. So let me go back to augmented matrix. Now that we remember what a coefficient is, augmented matrix is a matrix with the answers included, but the matrix that you are going to write is a coefficient matrix with the answers included, and those answers are going to go included on the right side. So for some reason, for me, this got shifted over. This should be over here. Normally, with your system of equations, they're lined up. I don't know, did your notes come out that way? No, they look right. So I don't know why that happened for me, but anyway. If the system of equations looks like this, now your note packet looks correct. If the system of equations looks like this, then the augmented matrix will be the coefficient matrix, which is just pulling the numbers straight off of those equations. So this will be my first row, this will be my second row. So my first row will be negative 2 in my first column, 7, a positive 7, so just 7 in my second column. In my first column for the second row, it'll be a 6, and then that's a negative 4. Now this is the augmented matrix, so we are including the answers on the right side. So I'm going to draw a bar down, demonstrating that those are, now I'm on, that's my equal sign, I'm on the augmented side, and I write my answers, 11 and 2. So if you notice, the top row, negative 2x plus 7y equals 11. We have negative 2, positive 7, and then this bar, positive 11. Second row, positive 6 minus 4y equals 2. We have 6 minus 4, the bar, 2. This is an augmented matrix. What? What do you mean the bottom one worked? Oh, that's total coincidence, yeah. This is not 6 minus 4. This is 6 in this position. This is negative 4 in this position. This is 2 in this position, okay? There's no math involved here as we read across. Those are just elements sitting there. Good question, thanks. Okay, write an augmented matrix for each system of equations or vice versa. So we can write the augmented system here, and here we're given an augmented matrix. I want to write the original system. So we're writing a matrix here, we're writing the system here. Go ahead and do that. What do I do for the system of equations to write as a matrix? There's 2 rows. I need my bracket. Three, negative 2, 6, okay? And then? Good. That's the augmented matrix for that system of equations. Now I'm giving you an augmented matrix. Come up with the original system of equations. What is it? So x. There you go. I don't have to write the 1. Yeah. So if I give you this system right here, are you going to put a 1 or a 0 there? There's a 1 in front of that x. Okay? If there's a 0, then you would see a 0. If you don't see a number, then it's a 1. I'm lazy. I'm a mathematician. I don't want to write anything I don't have to write. I don't have to write that 1. I'm not going to write that 1. It's not stupid. Okay, you're capable of doing 8 through 17 all, number 19, number 21, and number 23, and I'm going to give you some time to do that, so go ahead.